I'd like just to jump straight in with something that I heard about just yesterday. I'm still learning about, and I'd love to hear your guys' thoughts on it, because this is kind of a big subject that all of you are familiar with in the open source community. Yes, at the Open Source Hardware Summit recently, there was an announcement of the open source hardware certification. I don't know what you would call it, just the certification or the process for becoming certified. And I would like to hear your thoughts on how you feel that works, should it exist, and what should be required to be certified as open source hardware.
Have you guys read it? I haven't read it.
No, looking at you.
Okay, yeah. Massimo, did you read it?
No, I haven't. Did you?
No, I haven't.
All right.
Well, we can skip all that.
All right.
What do you think should be? What do you think should be required?
I did have a chat. I did have a chat with one of the person who is in charge of that. So that I haven't had the time to read it. I had a chat with the person from the Open Source Hardware Association who is in charge of actually developing the whole, the certification. I think it's interesting as long as it's not mandatory by law. No, it makes sense that there is an association that's like that groups a number of people who believe in a certain set of values, and they establish some rules that says, are you really open source or not? Obviously, open source hardware depends on when you draw the line, no? Because there could be a situation where a lot of people say that Arduino is not open source because we use a processor which is not open source. And that's depends on when you draw the line, no?
Is there actually a processor that is open source?
Yeah. I mean, but then you see, you could use OpenRISC, but then you would be using that on an FPGA, which are not open source.
And the thing that worries me about the open hardware, certification is the word organic, right? Because we've had this for decades now. Organic food. This is certified organic. What does that mean? What does it mean to the people that are buying it, and what does it mean to the people that are making it? It's a very different thing. And even though I'm sure there are pages and documents that are this thick that tells you exactly what the word organic means when it's written in the front of a product, no consumer reads that document. So it worries me to have an open hardware certification that will effectively be our community's organic stamp. Because it's going to mean something different to the people that are building it, the people that are certifying it, and the people that are buying the product.
I mean, for us, this is something we struggle with, right? There isn't a rock solid license that we know to go to. As people that are part of the open source community, with software, I know my way around, GPL 2 and 3 and MIT and BSD, and that's fine. But the nature of hardware it's completely different, right? What's protected by copyright? What's protected by patent? And what Massimo was saying, where do you draw the line? It's actually an enormously complex issue that I think patent law hasn't actually resolved. But for me, I think about it as what can you do with it? If something is open source, it implies that I can change it, or I can learn how it works, or I have access to the documentation that makes it more functional than, say, something that's completely proprietary. Yeah. And there's this sort of differentiation between open standards and open source, right? And I think ARM's very good about open standards things, but not necessarily about open source because their business is intellectual property. Yeah. So how open source could they actually be and still be a business?
Yeah, I think if something like this improves quality, and if I take a project and I can replicate it and I can replicate everything I need, not get 90% of the way through and have an issue that I just can't, I think that's valuable. So verification, quality, I think those are all valuable.
Yeah, I mean, one of the problems with a lot of the open source boards you find, especially on Kickstarter, for instance, is that they claim to be open source. They say they will open source the board, and what they open source in the end, you might get schematics, you might get something, but you couldn't build the board yourself.
Exactly.
Because you need schematics, you need the BOM, you need to be able to buy the bits on the BOM. Bill of materials for anyone that was wondering. If you can't buy the things on the bill of materials, you can't build the board. So it doesn't matter whether they've given you everything else. If you can't buy it because only they can buy the bits, it's not open source.
It's the fundamental point here is that when you don't open source something that is so integral to all of these projects that we're talking about and ultimately products, you're really making an assumption that you know what people are going to do with it. And one of the reasons that we're so advocates for open source around our hardware is that maybe someone is going to look at the register level documentation and implement something that we think is impossible, there are people, if you look at open source, that do incredible things that you seem like they must have spent thousands of hours. Well, they did. And I think people are starting to wake up to this idea, especially in the semiconductor business, that actually if we just open up as much as we're comfortable with, it actually is better for the customer, better for the community, and ultimately is better for everyone involved.
So at what point are you serving the customer with open source? Like literally, I mean, do you see people actually reproducing things beyond just a basic bill of materials? I mean, you said you've seen people at the register level on open source stuff. Is that actually a selling point for an actual product?
I mean, there's a number of things to talk about there. First of all, so if you go on our forum, we just started shipping these alpha boards today. There are people on our forum who are recommending different kinds of battery connectors, this little white plug on the front of the chip, which is like a whole other layer of esoteric on like what angle it should be based on the strain of the bending of the wires. It's fantastic, and we have real hardcore electrical engineers helping us with really technical stuff without even asking. It's free, and it's amazing, and it makes the board better. It will change because of their feedback in the next version, which is amazing. But ultimately, like that's what this is about, is making something that's useful for everyone and giving, in some ways, people a say to suggest things that you didn't even think about. It's not just about serving the customer, it's a different framework for innovation. It's about open innovation that we don't know best all of the time. We like to think that we do, but we're more in the business of giving our best guess and a starting point and working with the community to make it better. I mean, if you look, it's in the foundations of Linux where it started one place and ended a completely different place. And I imagine a lot of the stuff that we're all working on, I imagine, Arduino, it's amazing where it started, but did you ever imagine it would be where it is today? I mean, it's changed a lot.
No, it's changed several times in the process. I think what's interesting is that the question of serving the customer, because obviously the designs that we put online are being used by lots of people as a starting point to build other products, which they sold. And so we serve them in a way by giving them a pre-cooked sort of platform to start with. Obviously, that didn't increase our sales. So from a classic business point of view, it serves them, but serves less us in a way. I think one of the issues, to touch for a second on the question of the certifications and the licenses, for example, we put the Creative Commons license on our design. So technically, people should be releasing the schematics and the Eagle files, whatever, of the design based on our design, if they were to follow the Creative Commons license, but very few people do that. And the question is, how do you enforce that? So again, even if you create certifications and licenses, the issues of enforcing that, it's a problem. Since having spent several $100,000 in lawyers in the last year, I can tell you that sometimes you spend a lot of money and you don't get any result. So enforcing this kind of licenses might be a question of you do it either because you're making a lot of money or you're trying to prove a point. So right now, I think I'm doing it mostly because I'm trying to prove a point in a way. But there's dozens of situations that I know of people that started off from Arduino, and they should have released their files and everything in a modifiable fashion and everything else, and they never did. So we do what we do because we are part of a community. In a way, the community of makers are my shareholders, quote unquote, in a way. Even though it's like a more virtual type of shareholding, and I serve this community by doing that.
That's a great answer, actually. So one of the questions that I've been asked many, many times, and I personally have no answer for this that's intelligent, is how does the ubiquity of these development boards affect manufacturing? How is all this becoming more common? How is it truly affecting, and how will it be affecting manufacturing in the near future?
Well, one quick example that sorry to steal but one quick example that I noticed is that certain people who are there are some companies that are offering sort of manufacturing services to makers. And so I was looking at this kit of parts that Seed Studio, for example, makes available as a starting point for you to design your product so that it makes it easy for them to then manufacture it down the line. And it was essentially the bill of material of an Arduino board. And I thought, okay, that's we influenced, in a way, the manufacturing process, because people tend to try to use the parts that we use in the Arduino, because obviously you can start your project with an Arduino, then you evolve the circuit from there. And the manufacturers are sort of getting ready by having those parts available. And so in a way, more and more designs are now based on the work that we do. There are designs based on the BeagleBone, for example.
Yep.
There's people who are attempting to do designs based on the Raspberry Pi, but not being open source and the processor not being really available on the market makes it more difficult. I'm pretty sure that now you will see an explosion of designs based on your product.
Well, you have to, there's a sort of fun joke that we have on this board, right? CHIP is actually an acronym, CHIP. People notice the periods. What does it mean? Well, it means computer hardware in products. And that's sort of the idea. And our view of this is a little bit more meta. I mean, you've seen it firsthand. And I hope that people go where they've gone with the Arduino with what we've done. But ultimately, like, who gets to decide what kind of products are made, right? Like, we're talking about a 1 gigahertz processor, basically like a phone or a tablet. It's a very, very small group of people, right? It's designers and big companies we all know the names of. And they're the only ones who have access to this powerful technology. And when we go to the store, the products that we buy, they're chosen by people who are not necessarily like us. They don't understand our problems or what we want to make. And so it's sort of how it impacts manufacturing. The goal here is to create a greater diversity of products, to let somebody go and say, hey, I want to make a prototype. And then I want to make 100 units. And then I want to make 1,000, maybe do a Kickstarter. And then I want to make 1 million or 10 million, and I want them to be available in stores. And what this opens up is a sort of shift in power and a shift in availability of what kind of things get made, right? Where it's not a bigger tablet or a bigger phone or a different kind of watch. It's something we don't even know about yet that, is sitting in someone's garage and can't make its way out into regular people's hands because they can't meet this minimum quantity that maybe an SoC vendor requires, or they can't. That's really what we're trying to do here, and that's what the pricing is about, right? We don't have a volume discount, right? That's not something you do in this business.
Oh, I'm so dying to jump in. So I think your product is fantastic, and just for full disclosure, I'm waiting for my 2 to come.
That's right, you're a Colonel Hacker backer.
Awesome.
Yes,
Awesome.
excellent.
But I think first thing I wanted to say, it sounds loud, I think we're living in a time when there's never been more choice as well. All the way Arduino, chip, for goodness sake, fantastic. Raspberry Pi, Beagle, Odroid, the Qualcomm boards, the Dragon boards. And I think that's one of the points I wanted to make. There's this huge spectrum of performance. You can find the things you want and apply them. Of course, I'm going around the question about production for a second. And this idea of very esoteric, extremely expensive to make devices that feature first in phones and in tablets and things like that, they are coming to us mere mortals. I describe myself as a mortal maker, but they are coming to us faster. And the reason why I pulled out Qualcomm, the Dragon board, the 96 boards, really high-end board, was last year's premium tablet, huge chunk of processing power, now available for $75. And again, full disclosure, I've got 2 on order with Arrow. I buy things, make things. So I think it's an amazing time. And I think we're going to see a lot of that, personally, I think we're going to see a lot of that mobile technology move faster and enable this.
And this is,
and I think
not to pile on, right? This is supposed to be a conversation, but you said $75, right?
Mm-hmm.
Like our first product, Otto, was a hackable animated gift camera. I think Thomas has got one right there, which is great. And so like distributors all over the world wanted to buy that thing, which is awesome. We only sold 500 of them on Kickstarter. We couldn't make it for a price and sell it even in a sustainable way, not in a profit-taking way, at $249 because we couldn't get the volume. Right? Even at $50 for a system on module or $50 for a dev board, it disenfranchises all of the folks like us in a garage that want to take our projects and our ideas and make them accessible, make them available to a large group of people. So I mean, the unfortunate thing is like there is a great choice of these different alternatives, but at $75 for a dev board, where in a phone you can buy it at the store for $99, we can't compete.
Yeah.
And so my question is like, it's important that we be honest about what the state of affairs is, that like if makers are going to go from projects to prototypes to maybe Kickstarters to scalable businesses, we need to start sort of talking seriously about what that looks like. And this is a start, right? But it needs to be a bigger dialogue, I think. I mean, you guys have this made with Arduino certification, which is fantastic, which is basically allowing people to leverage your brand to get stuff into the market. And like, why is that the only thing like that?
I mean, I think there's also a flip side to this argument, right? Which is until recently, the only way you could buy a product is in millions, is in hundreds of thousands, is in large numbers. And I think the Peace Dividend from the smartphone wars, the ARM process is becoming so much cheaper that this, and all the sensors like the accelerometers and the gyroscopes and all of these things that now come in little chips that you can just buy for a couple of bucks and you can put on a board. This means that you can build products that you couldn't build before, and you still will never build in large numbers. You're never going to ship 1 million of whatever it is, like if the market is only for 1,000 of them. But the fact is that the boards and the sensors and all of these chips are getting cheap enough that you can build 1,000 of something. It might be more expensive than you'd really want to pay, but you can build a niche product now. Almost easier than you can go out to China or do a large production run of 1 million things. It's like, the long tail is coming to hardware. It's not just for content anymore.
I mean, I think we have to be really careful with the language that we use, and we have to be really honest about where we are as a group in this journey, which is like, we're not yet in the long tail of hardware, I don't think.
No,
okay,
not
so,
yet. It's coming.
So what I'm getting at is that like we have to really focus on this idea that even if you can build it, if you can assemble it from sensors and parts that you can get from anywhere, but it costs $150 in component cost to do, you can't compete with large companies. The only way we could make chip was to do a Kickstarter to get enough people together so that we could go to a semiconductor vendor and buy that quantity. We're bearing the burden and the risk to make it possible.
But if it's a product that you don't want in large quantity, it's now buildable.
But I think there's probably evolutions of what's happening right now where it will depend. I think in the very near future, or really even now in certain situations, it depends on what kind of manufacturing partner you can find. Because if the manufacturer partner already buys that part in a huge quantity, they can probably give it to you for the same price that somebody that buys it in another.
Or at least that price plus a little bit.
One of the things that, for example, it's happening with all these fake Chinese Arduinos that you can find is that there's somebody in China that buys a truckload of the processor that go into the Arduino because they want that price of somebody who buys a truckload of them. They don't really need all of them. So part of that gets resold on a kind of a gray market. So there's a bunch of people who are able to access that processor at that very convenient price because somebody just needed to buy a lot of them to get the right price point, and then in a way sort of finds a way to optimize the stock. That's like an unofficial process, I would say, but I think with certain manufacturing
it feels like the Hollywood system of the mid 20th century, where the only people that get to make movies are the people that work with the studios. And we saw it in film, we saw when digital video became a thing, and we got this great sort of choice. And all these stories got to be told that were not told before because they weren't something that somebody at a studio cared about. I mean, this idea of the independent cinema, it's just like where we are now in hardware, where there is a large sort of concentration of the decision-making power because of this inequity, right? Because 35 millimeter film is a fortune, right? Well, that's the point. Like you're saying, it's not about making money. I'm telling you, building computers for just a little bit less than $9 and selling them for that is not a fantastic way to make money, right? We're trying to prove a point, right? What we're trying to say is we should have the choice. And I think that message it's not rung out yet. And I think it's one of the reasons we come to talk about these things, to make this point, is we want people to make stuff. Shit, I want people to clone our stuff. I know that that's not something you guys have to support the development of the IDE and things like that, but I want there to be an $8 computer. right? Like it needs to be even more accessible than it is. But,
So I've heard the crowdfunding and Kickstarting come up a couple times, and it seems like that also seems to have quite a strong role in the leverage people have nowadays to be able to produce these things. Now, Arduino came along before crowdfunding was really I mean, I guess it existed, but before it was really a thing that people did. And Chip would only exist because of crowdfunding, right?
it wouldn't be possible without Kickstarter.
So I'm kind of curious on your different points of views. Like, would you have used crowdfunding, and do you guys feel that crowdfunding is having a net positive on innovation, or what are your thoughts on it?
Well, obviously, yeah, probably we would have used some sort of crowdfunding. Actually, the very first batch of pre-assembled Arduino happened because, we found roughly enough customers to pay for half of that. So we wanted to make 200. So I found, my school said, okay, we'll buy 100. And then David Quartieri's university in Sweden said, okay, we'll buy 100. So, we buy 50 and 50. So 100 were sold. It's okay, that's, I'm confident that we might be able to kind of sell the other 100 to people. And so that's how we kind of funded. We put 2,000, I think we put 2,000 euros each to kind of kickstart that sort of process. But in a way, we found some customers beforehand. But I guess at that time, the market was so tiny and non-existent that, already 200 of these boards seemed already a little bit of a risk.
Yeah.
I mean, the first 300 I paid out of my own pocket. I bought just the PCBs, and I just gave them to people as a way to start the business.
I mean,
That's a good question. Depends on what Arduino you're trying to, which Arduino has sold what. And also there's a bunch of, clones, fakes, compatibles. The only thing I can see that from the other point of view, there's about 6-7 million people who come to the Arduino website on a regular basis, let's say at least once a week or something. The whole overall visitors in a year is about 21 million, but of these 21 million, about 6 to 7 million are regular visitors. So this means that if you put together all the products and all the things that are sort of Arduino compatible, there's at least 6 to 7 million people who are engaged with the platform.
and I mean, I think the downside of crowdfunding, at least for Arduino, is the sporia of Arduino compatible boards that have turned up on the crowdfunding sites, right? And that's not necessarily a good thing for the community because they buy it and it's Arduino compatible and doesn't necessarily do exactly what they think it does, and it doesn't work exactly how you would expect. And there isn't actually a lot of innovation going on there.
Oh, come on.
Oh, yeah.
Come on.
All right, come
on. I'm not letting that slide.
Go on then.
I mean, it's open source hardware. This is our bed. We're going to lie in it.
Yep.
Right? Like, I mean, to be frank, as a hero of mine, I feel bad saying this, but fakes, like, it's open source. Like, there's authentic. There's authentic. There's authentic. It's fine.
Saying fake versus, I mean, in the open source hardware, it's one thing.
Compatible
And
is
then,
one thing.
calling yourself Massimo, it's another thing.
Sure.
So if you go around and you say, I am Massimo Banzi,
it's your trademark, right?
I'm
Yeah.
allowed to say, no, sorry, maybe not. But, if you say this thing is based on the Arduino.
I should say we tried to trademark Chip, and the trademark office rejected us because it was too generic. So people can actually make clones of Chip as open source. They can download the files today, and they can call them Chip.
Yeah.
And it's going to be a problem, and I hope it is, right? It's the most sincere form of flattery.
But even if you had a trademark, they could call it Chip, and then it's defending the trademark will cost you a lot of money, and very few people will help you.
But we need. I mean, that's the thing is. No. It's, of course. I mean, the thing to say about it is that the whole point of this is that we want as many people to use it and do as many things with it as they possibly can. And when I say open source, I mean it, and I mean that. It's going to be a nightmare for us.
Sure, but surely you want them to do innovative things. You want them to do different things, right?
Of course. But that's you got to take both, right? And there's going to be an enormous sort of freeloader problem in the economic sense, where just like you'll build the IDE, right? That's an enormous amount of energy that goes into that. And all of these folks who build these copies of the board get to use your software that they don't support, right? And like that's a huge problem, but here's the thing, you're the standard, right? Like we all used it, and that's awesome, right? And it means it's now easier to make things talk, make things move, make things blink. That's fantastic. And for us, we're talking about trying to make something that is not possible today possible. And if the best way to do that is to basically give up any chance we have of ensuring that it's made by us, so be it. I mean, it's what's, in my mind, like when you look at what Linus did when he created Linux, he's like, I made this thing, and here it is. I want it to exist, right? It's not, he didn't even name it himself, right? And we have this great history where it's about making the thing. Just by any means, and open source is this great mechanism where it becomes bigger than just the company. It becomes the property of the community. And sometimes that has a number of challenges, and we have a lot to learn from you guys, right? But like, it's, that's just, we chose it. We copied your license. We're using the same Creative Commons stuff on our board. We just looked at yours.
Did you copyright the license?
Please go ahead.
I mean,
No, but in a way, I'm glad that a number of people are able to enter this business because they basically, look at what we have done and they're picking the good parts, in a way.
One of the things that, I get, as an editor, I get 10 or 12 press releases about new boards every week, right? And my inbox is full of these things. And you actually use the exact same words. My yardstick for whether I'm going to write about this, whether it's interesting, whether it should have been done in the first place is, does this let me do something today that I couldn't do yesterday, right? And that chip, for instance, lets me do something today that I couldn't do yesterday. I can throw it away because it's cheap enough, right? The ESP8266, like this little $2 Wi-Fi chip that's everywhere right now. It's $2. It has like 2 I/O pins or something in the standard breakouts. But so what? That's enough for a subset of projects. But it's cheap enough to throw away to certain values of cheap. And that lets you do something that you today...
It's pronounced chip, but still.
Meh.
Yeah.
So yeah, I'm all for the compatibles and the clones and all of these things, but if people aren't doing innovative stuff with it, that sort of just disappoints me.
Well, I don't disagree with you, but the thing is, we want people just to be doing anything, number one. And like to look at chip, and like we had to say it was a $9 computer because that gets people's attention.
Yeah.
But it actually might be one of the least interesting things about it, right? It is the first dev board, which we don't usually use when we talk about it publicly because it's confusing for a lot of people. It's the first one of these things like this that's built by a team of people building things, building products. Yeah. Right? Just like the Arduino, you guys were working as artists and you solved your own problem. We made our camera and we needed to solve our own problem. And we always talk about what you guys do is as a model where it's like, this is us, in the parlance of Silicon Valley, which is kind of nauseating often, is just dog fooding, right? Like we're trying to eat our own dog food, which nobody really should do. But yeah, that's the thing, is that's what's really different about it. And I think that people haven't really found that yet, and it's probably because they just started shipping today. Hopefully, when we have this conversation a year from now, like I can show you, when we ask them what are you going to do with it, we have 150 people put comments on a post. 3 people want to send it to space, right? Like 5 different people want to build autonomous robots. People want to do VR stuff. They want to do all this stuff, and frankly, it's not my call to decide what's interesting and what's not. My call was to say it's open source, do whatever you want, and enable that, right? But if I knew what the right thing to do with it was, we would just do that. We wouldn't be in the business of giving this thing away like we do. We would just make that thing. But this is really for us about finding out what's possible. And all these decisions were made as a mechanism to enable that. Open source, low price, including the storage. All those things are all about this one idea is, what happens if the computer is free? Right? Like, what happens if you can program anything? Right? Like, it's just an essential question that remains completely unanswered. And that's really what we're trying to do. And I think I don't want to get in this situation where like, just because we can't see today what is interesting or what's not, that it doesn't matter. I don't want to be the guy that went to the Homebrew Computer Club and told Woz like, nobody wants a computer. I mean, come on, like that doesn't make any sense. What are you going to use it for, right? So we don't know. But yeah, to your point, hopefully people will do interesting stuff.
Yeah.
So these boards are everywhere. We see thousands and thousands of people building stuff, with this. I mean, this is our day jobs, is just finding these stuff that people build with these. So we know that it's popular. And I'm curious, and Mark, you might be able to shed some light on this here. When you get into an industrial setting and manufacturing, are you seeing this transition into that, or does it stop at the hobbyist?
Okay, I think first point, there's a huge amount of choice out there. You know, from the tiniest piece of silicon that we can't see, all the way up to the example I was making of the Qualcomm board, which excited me because of its unprecedented performance at that point. I think people are using everything. I think we're seeing people using Beagle. We'll see people using that. We see people using Arduino. And we're seeing them put those things, extend those things in products. They sometimes take them, and there's a push for modules. I think that will be incredibly popular, even though we disagree on other things, because people want to try markets, and Kickstarter is amazing for doing this. I think, you know, okay, just to take this in one direction, we make 5 microcontrollers. Our partners turn that into 2,500, from tens of cents up to, I'm sure, tens of dollars. And I don't want to talk about ARM, but that's choice. And for each of those, there's lots of boards out there. There's fantastic communities. There's so much choice. And so you can test markets. You can move to modules. Or you can try and do something different. You can take the open source and maybe modularize something, use the economies of scale to move in a different way if you have volume. You can always do custom things as well, so much. But you're right, I see people doing all of the above. And the fact that we can point to all of these as options, I think is fantastic.
Now, you mentioned ARM. Discussing amongst some of us editors, we were discussing the boards out there available. And it seems like the trend is to move towards ARM right now with the chips. Explain why that might be, if you wouldn't mind. Why did you choose ARM? Why are we seeing more ARM, you know, in Arduino products?
And may I? Because just to make this point, I think, you know, we have processors that give you choice, and I think, you know, we don't sell chips. We make things that other people make into chips and make innovative products that then result in things like that. Fantastic volumes in certain areas like mobile allow things like, I think you put it perfectly, sensors, storage, processors that we couldn't begin as a small companies to make. And the fact that you can, at the smallest end of an architecture, you can have something that's 1 by 1 by 1 millimeter. I told you I was going to bring it up. 1 by 1 by 1 millimeter with a microcontroller on it that can take solar power and live forever doing something. And at the other end, you can have some kind of enterprise server and anywhere in between. And I think the fact that there are so many volumes and those fantastic companies make the volume stuff, I hate to say the phrase trickle down, but we can take advantage of it. And I see more examples of things. You know, Odroid, BeagleBone, Pi 2. You can even ask Pi to do you a custom board. Things like that. So I think it's never been better.
So I'm reminded of what Winston Churchill said about democracy. It's not the best, but it's the best that we have. And that's, you know, I mean, ARM is the absolute best architecture right now in the world for doing the kinds of things that we want to do in terms of power consumption, in terms of performance, in terms of price. But again, there is a great variety of choice in ARM's portfolio, and all of it's awesome. But we are a completely open source product that has one key piece supplied by one commercial company, right? I would love it if we had other people to go to. Not anything against ARM, stuff is great, right? But you know, there should be more choice, just like there shouldn't be one mobile operating system, there shouldn't be one desktop operating system. There should
Absolutely.
be just this sort of panoply of choice, right? But the thing is, for our product, our goal is to make it as easy as possible for people to make things, like across the board. And that's all about how big is the community of people that knows how to use the tools that are required to do it. And hands down, when you're talking about portable stuff, embedded stuff, it's all about ARM. That's where the nexus of community is. The only way that a small team of 9 people was able to go from let's do this to let's build a functional computer with a complete version of mainline Linux we shipped basically in less than 90 days is because of the foundation that ARM has worked so hard to build. Yeah. And it's that thing that's made ARM successful. And whether or not their business model is brilliant, but like honestly, we're very similar in the way that we think about it. ARM has worked really hard to enable the community, and that's what's so cool about it. That you guys are here is great.
And I just want to come back really briefly. I'll let the others talk, but take us out of the equation. You chose us, you small team, 9 people were able to make a product because of the things other people have done. So Linux, Android, things like that, fantastic community. So I think the wider community, Linux, for goodness sake, people develop on it, put it back, and it just gets better and better. So thank you.
I don't know if that answers your question, Gail.
I think I think the main issue here now it's all about the tools.
Yeah.
Because there is so much choice in terms of what kind of hardware you can use. There's a huge amount of choice. So now when you're developing something, the problem is the tools. So at the end of the day, you wouldn't be able to do this if somebody hadn't developed Linux. Somebody else hadn't made Linux run on that particular processor. Because also there is this thing that, we have migrated Arduino on several different architectures, either ourselves or working with other people. And even within the sort of ARM family, every processor is different. The core is the same, but the peripherals are different. And what they can create issues there is, adapting to all this. So every time you move your software to another platform, it's all boils down to the quality of the work that people have done on that particular architecture, that particular processor. So you were lucky in a way that there was a lot of work done, or when we did Arduino, we were lucky that there was GCC that was already working, and so we chose AVR in the end back in the days because there was GCC, it was working very well. There was a huge amount of work done by the community to document that particular architecture, and also I guess it has to do with the fact that one of my mentors from Stanford told me, "Oh, we are using AVR at Stanford. You should be using AVR." But apart from this, there was this kind of all these tools ready. What struck me back at the time, there was this article on a website from MIT website that says, "Oh, using GCC on AVR is very simple." And then there was like a 1 kilometer long article where this person proceeded to compile its own version of GCC and then compiled all the tools. And then I did it. And I got stuck several times because nobody told me that if you have a computer that's not set for the US English, the compiler would fail. And, so there was a lot of things that. And in the end, to get this binary file that you could use to compile C code for the. So in a way, that kind of told me that there was a huge gap in the market for the tools. And I think it's still about the tools. And there's actually a great talk by Bunny Huang about how the processor are becoming, the rate at which the processor is becoming faster is actually slowing down a bit. So it becomes more about the tools and the user experience. So it will become more about not the most powerful processor, but who builds the tools that make it easier for people to build stuff with their processor. Because honestly, we have more power than we need in a lot of situations.
And I think there's an interesting analogy here with the desktop market. I mean, about 15 years ago, if as the geek, someone came to you and asked, which computer should I buy? Right? And you actually had to ask them a list of questions. Says, what are you going to use it for? Do you need storage? Or these days, if someone comes to you and asks you what computer you should buy, you should go like, whichever one you like, pick it. Does it run? Which piece of software do you want to run? Pick it that runs that, or it doesn't matter. It's the shiny one, the one with the Apple logo, or the one with like the HP, whatever. It doesn't matter. It doesn't matter anymore which computer you buy because they're all fast enough. And I think there's an analogy here with the boards market is, which board should you buy? Well, the one that has community, the one that has support and you can solve your problems. Because what you want to do is solve a problem. You don't want to have a board.
I mean, technology doesn't matter. People do. It's all about the people. That's all that matters here. And we've tried to take that as far as we can. But as you've seen, compiling GCC, which we've done as well, is pretty challenging. It takes oftentimes a group of people to coalesce around this sort of frustration right? Because there is just so many different things you can go after, and it's hard to discern from the people that are confused by this. Right? People would say like,
Yeah.
They're very concerned with what the features are, not the benefits. The benefits are I can make stuff, right?
Yeah.
It's got features, and I only have to say them because people care about those things, but they don't really matter,
Yeah.
right? It's what are the benefits? What can I really do with it? And I think there is a lot of this sort of competition and discussion about like, or who, people ask me, who do we compete with? And I'm like, well, nobody, right? Like, we're not thinking about what the competition is doing. What we're trying to do is like get rid of the pain that we face, just like you were talking about, that pain of doing it, so that nobody has to replicate the work.
Yeah.
Right? And that's, I think, as a community, what we haven't been really good about is sharing the solution, right? Like embedded Linux or even microcontroller stuff, like there are millions of products made with this stuff, but it's not available to us. Like it's starting to become more and more and more repeatable, but it's still like sort of trapped in this little world, right? And I mean,
I'm going to have to disagree. I think it's never been more open and more available.
oh, for now for sure,
Yeah.
but it's now gotten to this point,
Yeah.
right?
Yeah.
Like, but I can tell you that there hasn't been a single embedded Linux product that you could buy for this price, naturally, like that ran mainline Linux with mainline U-boot with open documentation for both the bootloader and the processor itself, like all the things you need to really customize it until we sort of did it, right? And that's strange, right? And it's strange because it feels a bit like we're carpenters and we can only buy wood with a license, right? And like that was sort of strange to us, like this is the material of our trade and yet we can't get access to it. But it's okay, the problem has been solved, but it took the community to come together, so it's sort of full circle there, right? Where now like the community has spoken, great, now it's available. The hope is that people do interesting stuff, like you're saying, and it's all not for naught, and this becomes the way that we think about how we enable people to do interesting stuff, right? It's not the big accounts anymore necessarily. We can really put our money where our mouth is and say, we actually care about the 50,000 customers that are going to do interesting stuff in their garage and they're going to turn into these businesses, and not just the 1,000 or so traditional customers that can supply us with the 10 million unit orders.
So what I'm hearing is that really, I mean, at this point, the hardware maybe doesn't necessarily matter. I mean, it could be MIPS. It could be a hamster.
I don't know if it could be
I don't
MIPS.
think it could be
I don't know if it could be
MIPS,
MIPS. Yeah. Who put you up to that? first of all?
David Shelton. But really, it's the tool chain in the community, right?
Yeah,
And
it's mostly the community. I mean, the tool chain is a solved problem if you have enough people.
Sure. But in the tool chain, there are a couple different approaches, right? There's taking an operating system and giving free reign over the operating system like Linux, or there's the tool chains that you would see with Arduino, where you're getting down into like kind of the GC stuff, right? And I'm kind of curious where you guys see this going in the future. Like, is Arduino going to stay with kind of that development platform as the hardware gets more powerful? Or are you going to go into more of an open operating system like Linux embedded on the stuff? Or, I mean...
Well, there is a slide I show sometimes when I give presentations where now there is this thing that there is a whole stack that Arduino provides. So Arduino right now runs on bare metal, on a number of architectures, runs on Linux, runs on Windows 10 for IoT, and runs on a number of real-time operating systems. So you can run Arduino code on top of all of these platforms. And we have a number of APIs that are growing that go more towards the kind of the IoT connectivity and Wi-Fi and all that. So in a way, we have a set of APIs where when you say, okay, let's connect this socket, on something, it will go through a chip and sort of bare metal, and something else will go through the Linux stack. So in a way, we're sort of abstracting away all these things. And also we created, for example, UI frameworks that allow you to manage your sort of, if you have an embedded Linux machine and you want to control the sort of the parameters, we have that. So we have a number of layers to the top, to the point that for this Arduino tray, which one day might come out, we had this kind of IDE built in HTML5 that just runs on the device. So you just open the browser, point to the device, and you code. No installation. So in a way, we have that stack already happening. So people can move from an 8-pin microcontroller, an 8-bit microcontroller, which has like 256 bytes of RAM, over to an 8-core ARM Cortex-A 9 or something. The Arctic from Samsung is an 8-core, or you can run it on, on the Intel platform, so you can run it on all of it. So I guess that there's a lot now. You can use this kind of programming model from a small device to a very, very big device. So I think there is more work that needs to be done in creating tools that are more powerful, that make it even simpler for people to build something quickly and then choose the right computing power for what they want to do. Because I think a number of engineers, when they design products, they tend to say, okay, let's put the most powerful processor, because just in case. Well, there's an interesting, I think we should probably sometimes should be more careful and choose the right amount of computing power for what we want to do. So the tools help you do that. So I think the user, as I said multiple times, but the user experience, the quality of the tools is what will drive a lot, continue to drive where makers go. And the fact that people are still running Arduino code on these monster 8-core processors, it means that that particular layer, the way the tools are designed, are more important than, in a way, the kind of hardware it's underneath. So that's one thing, I think. And the other thing is, I think we're going to a stage where people are going to have to create products faster. It's becoming, in a way, the market is probably becoming a little bit like fast fashion, where you have to have a different product every season. So you need to kind of churn out like 4 products a year.
Yeah.
So the way you do that is by having more productive tools and by modularizing a lot of things. So the question is that if you have standard modules that wrap certain functionality and you can kind of exchange these modules, you can quickly upgrade and adapt your design. So in a way, this little thing you built, it can be the core of a product. But I'm sure that at some point somebody will use the same pinout to put a processor which has 4 cores. So that whatever was designed around that particular pinout will, still compatible but have more power. So in a way, this kind of speed of change and again brings back to what are the tools that you use? How can you make the whole development process simpler? And this is one of the things that we're trying to do right now, to integrate different steps of the process. So we have this online development environment that I'll show you on Saturday that connects to a cloud platform, connects to a bunch of other things, so that you stay in that tool for a lot of the process of developing something.
We almost agree wholeheartedly about sort of on a meta level, but in terms of how it gets implemented, we're probably in different camps, which is good because it needs to be on both sides. But like simple challenge, right? You want to make a camera and you want to take animated GIFs. That's that simple. That using a Raspberry Pi, like that takes a very, very long time to figure out the first time you do it. It took me almost 2.5 weeks to do it reliably. We're like actually at GAFTA, Josette's here, right? At a party that Josette threw as an animated GIFs. It was a gallery show, and we wanted to have a crank on the side of this big wooden box. And when you turned it, it would just take still frames and then turn into a GIF. That's when Auto started as an art project. And it took an enormously long time to do this. And you used to think it's like really, really straightforward to do this. And it turns out there's no sort of recipe or established best practice for how to do it. And it's a challenge because there's clearly all these products around us that are doing these things, and it feels like it's sort of like dark art. Like you put your key in your car and your GPS just comes up, and you're like, wait, how does that work, right? Like how does the process run and all those sort of things. And so when we think about tools, right, like we're not quite to the point where you guys are, where you have this model for what people are doing with it. You have this amazing set of examples in the IDE. We always point to it, like what's our Blink? What is Blink for Linux, right? Like that's the thing. It's like, how do you get people started? How do you onboard them into this ocean of power, right? More power means more flexibility, means more confusion, right? And so the question is like, we're trying to figure out first like what people want to do. What does the access and power enable? Like, what about voice recognition? What about computer vision? What about real-time processing? What are all of these sort of frontiers that we haven't seen in projects in mass in Make? I want to get to the point where like, you can't stop like getting submissions for projects that are all computer vision. Like that hasn't happened yet. That's now like an interesting thing. But very, very soon, when there's all this excess power being used, if we can figure it out, like we're going to actually change the kinds of things that people make. I think you guys are going to perfect that system, but I want to find out what the new stuff is, right? We're not in the business of helping people solve those problems just yet. It's just a question of what are the new things? Like, what can you actually do when there's that stupid amount of power?
But in order to do that, you need to make choices. Because one of the issues of a lot of these sort of embedded Linux boards is that whoever makes them says, oh, you can use these 25 different languages with it, which appeals to a certain type of maker. But somebody that doesn't know how to do the things you just described, when they say, oh, I can use 25 different languages, in their brain, 25 multiplied by 0, because I don't know anything, comes out 0 is the result. So if I can use any tool, then whatever, I'm not going to start. I don't know where to start. So in a way, in Arduino, we made some choices to stick with a certain model. Yeah. And so what we try to use is a certain consistent model of how we shape APIs, how we do things. So in a way, if you at some point, you have to make a choice. So you say, okay, I choose Python. Then Python comes with like a zillion different libraries. Then I choose my own style for designing those APIs so that people find this consistency very helpful. Because when they say, oh, I just made an audio player, now I'm going to make a video player. Oh, look, the API is very similar. Oh, I don't have to reinvent the wheel yet again. And that takes a lot of discipline. And a lot of people are not willing to do that because each developer thinks that, my way of doing things is the best in the world and everybody else is wrong. And it's understandable, but it takes a lot of discipline to say, this is the standard, this is the philosophy we selected, and we just go with it. So some of the things that we are starting to import into Arduino is we have now an audio player API, and in some of the platforms, we can import other people's work to do all the other things.
The new plugin installer is awesome, by the way.
Yeah, because again, that's the problem with the complexity. At some point, you need to go to some kind of a, let's call it app store model, where you don't have everything in the platform, but you just use it. But the discussion about the tools could last for the next 7 hours.
Yeah,
absolutely.
I think the choice thing is very evident in the smartphone market, right? It's the diversity of the different types of, just the ergonomics of the phones you had before the iPhone came along. And since the iPhone, there has been black rectangles. But despite that, the choice you got in the software side of things has enabled a whole bunch of different tools and blocks to be built, right? That you can do voice recognition, you can do image recognition right out of the box. It's really trivial to do. And the amount of power and the innovation that's driven, it's going to be interesting to see hardware, which is sort of getting to the stage where the really early smartphone type stuff is trivial to do.
It's really, the tools thing really could go on for weeks. We could talk about this. But the thing to say is, like, what's important to us is that there is a strong choice made, which you guys have succeeded at enormously. But at the same time, there's still the openness that if you want to ignore every decision that's been made, you can do it, right? You can always just, compile your seed around the AVR and you're fine, right? Mm-hmm. And that's the brilliance of that choice, is where to draw the line and at what point where the ceiling is, right? Because, I'm not sure, I'm curious what your experience is, but like people shipping products, do they keep the Arduino bootloader when they ship it to mass production?
I certainly, as someone who has done contracting work to put Arduinos inside products that go into the high street, and I'm not allowed to say who because they make me sign NDAs, so I'm not allowed to say, but yeah, lots of people do that. And some of them even have the blue boards embedded in the middle of these things.
Okay, we could go on and on. Yeah, we go on this. We all agree. We could talk about toolchain forever. We're getting down to our last 15 minutes. I want to open up and allow some questions if anybody has any questions in the crowd. So here, yeah.
Going back to the open source discussion, I come from a tool vendor as well.
Which one?
Altium.
Oh, yeah. We use Altium. It's awesome. Yeah.
But what's always puzzled and bothered me is I love the idea of open source hardware and open source IDEs, but what I can't easily resolve in my mind is at where that line is drawn, which you guys touched on. At some point with open source, it's not open source anymore, and that's at the silicon level. I can't just make knowing that that line is there, what can we do as an industry to make it easier for companies like Arduino or other open source hardware design houses that they need to feed their children, but they're also very exposed? What can we do as an industry to protect them a little bit without making it closed source?
Okay, so the question was, and let me see if I can paraphrase this correctly. How can the industry, in a way, protect the creators of open source products to keep them from being destroyed by their own open sourceness, right?
What is advice as veterans of open source hardware?
What would you like to see the industry do to help you?
Well, you see, I've had a number of conversations in the past years where people have said, oh, I have this chip, and if you add it to your board, you can put some encrypted thing that when somebody plugs it into the computer, you will be able to detect that it's not your board, and yeah, but that will kind of sort of ruin the whole openness, and the community will beat me up at the next Maker Faire, and I don't think I want to do that. And so there is, being open source at different levels opens up other people to be your competitor. I mean, one of the things that I think if people are competing with you in a sort of honest way, it's nice, it's good. I always thought that looking just at the business side, I'm much happier to have 30% of a very large market than to be 99% of a stupid market where it's like me and other 3 people. So clearly, I guess, if there is a large market and there is a fair competition, then it should be easy, to say, I'm happy to have a smaller chunk of a much larger market where we sort of compete and sort of collaborate. And I think that's one model. The recent events demonstrate that it's not the open source hardware issue that it's here. It's other issues like what happens if you call yourself us, or what happens if you show up at Maker Faire in California and you put up an Arduino banner, and I don't have, and the lawyer says can't do anything about it. And then it's, oh, what? So then it boils down to, if you try to build your business based on differentiating yourself with your brand, and then essentially your brand is, if you are small, it's practically impossible to protect yourself effectively. I'm not sure exactly what the tools can do to help us. It's more the people go in and say, could you possibly take down that banner and stop calling yourself what you're not? It's more about the people and less about the tools. To look at my sort of, the way I look at the market. I'm happy to be in a competitive, fair market and have other people benefit from what I do.
Can I ask you a slightly different question?
Sure.
That's almost the same thing. Is the open source the most important thing about your board? Is that the thing that you consider the most important piece?
The most important thing is that it was designed with the sort of idea of making things, right? And that's the key thing for us, right? Like you can look at almost every decision made about this thing, and it's either to keep it $9 or to make it easier to make things, right? Like why do we have the pin headers? Why are they 0.100? So you can use jumper wire, right? It would be smaller. It could be even smaller and thinner, right? Why are there holes on here, which we could actually make the board even smaller? We put them there because you can bolt it onto stuff, right? And the open source part of it is an important characteristic of enabling you to make things. I don't want someone to see this and say, oh man, I can finally add that computer vision to my project, or I can finally add audio or whatever it is I want to add. But I'm worried because it's not open source if I can't change something, or what if they raise the price, all these sorts of things, like all these concerns, they go away, right? And that was sort of the idea there. And the other thing to say is trying to present a reference implementation. What does an ARM v7 processor with completely mainline Linux on it, which if you don't know what mainline Linux is, it means like usually when you buy one of these things, there's like a special version, like imagine like Windows 3.11 for work groups. Like it's like a weird variant of the OS you have to install. We wanted to make sure that you could just use the basic one without any changes. And that's the thing that was the union, like Massimo's saying, of making a choice about the hardware and the software and the tools and saying, this is a different level than you're talking about, but it's like, look, this thing works with the industry established standard. And that's probably the most important thing technically about it. But again, it's also $9, which is kind of cool.
Okay. Yeah. I'm going to turn around to you. Sorry, I wanted to ask this question. So there are older ARM implementations, right? There are older processor designs. And the only thing that right now that you can't do in open source hardware, you know where this is going now, you've got time to think about it. The only thing you can't do right now in open source hardware is build an IC. You can't build a chip. Would you see ARM at any point in the future? Feel free to tell me to go away. But would you see ARM at any point in the future taking those old designs and open sourcing them?
Okay.
Or is the IP so interwoven that it's just not possible?
There's about 15 different ways to answer that.
I know.
So if you want the pain and misery of making your own IC, to your point when you were starting this off, you can build an open source platform, the software. There's so much out there that gives you a leg up. Yeah, the specifics of what you're doing might have to be tweaked and such, but the software, the hardware, and everything else, there's just so much out there, you can do it all. When it comes down to the chip, to make a chip that uses milliwatts of power, a standard processor, takes effort, it takes a team, it takes a lot of processors and stuff. You don't want that agony. Yes, you can take a core from us, put it in an FPGA, and implement a system. Lots of people do that. It won't reach those low power. It won't reach the small package. We've got some fantastic FPGA partners, but the newer tech is always better in every way than the older. So I don't know, it's smaller, it's lower cost, and that's
Careful.
So Alistair might have been referring to something like an ARM7. Still selling great. People are using it in a lot of products. Fantastic. But if I was going to design a new product, I likely might not use it. I would use something like a Cortex M3 or something. This is too ARM specific. But there's no good reason to. No.
I mean, be wary of the market leader telling you don't want to do what we do because it's messy and too difficult.
So the short answer is no, there's no good reason to do it. No, we're running really close on time. I want to get another question in here. I've got a gentleman in the back there, yeah?
Well, open source does not mean that you're not required to give attribution to the creator of the original product. And if you want to take, from the publishing world, there is a set of ethics, that exists, and a body that exists that looks at ethics in terms of, using and providing attribution and plagiarism and things like that. And maybe the industry needs a set of ethics, that people abide by in using open source hardware.
It needs a standard, an accepted license that's supported by legislation, which is kind of where this conversation started, right? Which is like, nobody can agree on what it is. Like written word is, the copyright law is a field that's well understood, and open source hardware is
it's also a minefield, though. It might be well understood, but it's a minefield. It's like copyright law is not easy.
Okay, up in the back with the hat on.
Just for the record, the Propeller One did release open source.
All right, the Propeller one did release
actual
open
designs
source.
of the processor. Yeah. It was a really cool processor.
The guy who designed that was named Chip, actually.
Oh, right, how about that?
Fantastic. Any questions for our panel? No. Okay. So we do have a little bit of time, and here's something I've been noticing. We have a lot of people that have been shouting that we need to manufacture locally and bringing manufacturing, to the States or to your local area, wherever you're at.
There's three non-Americans in the panel. Be careful here.
Well, that's why I said wherever you're at. Right? So wherever you're at, local manufacturing is very important, and you hear a lot of talk about it. And then you also hear people talking about how manufacturing in China is really the way to go. And I've seen that a lot of times it's the same people. How do you weigh the differences between getting your product manufactured maybe cheaper in China and maybe more expensive locally with what you deliver your customer and how that price
It's not necessarily cheaper to manufacture in China, depending on what you're manufacturing and depending on how you're manufacturing it.
Okay.
So the answer to your question is it depends. I'm sure the others might want to give a longer answer, but the answer to the question you actually get is it depends.
And if I may, I completely agree. I think if you can have something that's packaged and small, So small is one thing, so size rather is one thing. You can manufacture in China, so I work with a lot of startups that do both, and having something handed off that's small comes across back to the US or Europe in a big container. It's self-contained over there and simple, can be done in China. And again, there's the other aspects, so there's form factor, there's volume, and so many other things. But if you're making something complex and you have to physically manipulate things and build things, it's so much better locally, in my opinion. And I used to, before ARM, I used to work in volumes of 1 to hundreds of thousands. In the UK, I used to work with a contract manufacturer down the road, and it was so valuable. So valuable. So yeah, not necessarily cheaper to have things made overseas.
Not necessarily cheaper to have things made overseas.
You make stuff in New York, right?
Yeah, you can take the subway from here and go to the factory in less than an hour.
But from Italy, that is overseas.
Sorry?
That's overseas.
All right. Okay. No. So, well, I think from our point of view is we try to make some things locally. So we now manufacture in the US. We manufacture in China for the Asian market mostly, and now we manufacture also in Europe. So we have a range of manufacturing in different continents. I think there are some products that you can manufacture almost everywhere if you get the right supply chain. Obviously, somebody in New York is a little bit more expensive as a worker than in other countries, but there are some manufacturing processes that are highly automated so that
Yeah, it's about optimizing the product, right? If you optimize for different things. You optimize where
Yeah,
labor is
so-
cheap, or you optimize where labor is expensive.
And also sometimes you need to choose vendors, manufacturer, because they have the capability to work with a certain technology. Especially if you're working with RF and you want to make an RF module, there might be some manufacturers that are more suitable for that particular job because they do that. They do RF, they know how to do all the certification and everything else. So a lot of those manufacturers may be in Asia, so you work with them. So I think it's a question of tap into the right supply chain. Obviously, some of our products end up in educational markets, and in a lot of countries, I would say people like the idea that they are teaching their children with something that when you pick it up, it says made in the US or made
And your
in
custom
Europe.
solder mask color also is pretty awesome.
Well, yeah, we work on that, and we work on those little details, but maybe at a high level, people don't think they matter, but in a way, they give a little bit of a personality to what we do. So I think there's a combination. There are some products that make sense to make in Asia because there are manufacturers that are good at doing certain kind of volumes with certain kind of products. Some other things that you can make in the US, in Europe, if you find the right manufacturer that has access to the right supply chain. Because again, you can buy the same resistor for different prices, and you need to have a good supply chain.
That's great. Well, guys, our time is up. I want to thank you guys for giving us a little peek into your minds and discussing these topics with us. Dave, Massimo, Alastair, Mark, thank you very much for your time, everybody. Thank you for coming and watching.